I'm going to talk about a company called PJX Resources. This is an exploration level company. It's Canadian listed. Go to the next slide. It's one that hardly anybody's heard of, but it has been around for a while. Okay, this company has about 160 million shares out. You can see fully diluted a bit over 200 million. So it's been around a while. It's been out there a while. We've recently decided to take a stake in this company. I think it's made a significant discovery that could result in one of the most important zinc discoveries in a long time in Canada. Okay, now this chart is a bit dated. I think soon they'll have an updated share cap table for everybody to look at, but it is what it is right now. Okay, it's trading, I think, 24, 25 cents, something like that. Let's go to the next slide. Canadian, by the way. Okay, so what the heck are they looking for? What is their target? Well, they have a land position in southern British Columbia, and I'll show you that in a minute. But they're looking for SEDEX deposits. These are sedimentary deposits, so they're layers of rock that form at the bottom of the ocean in this case. So they're sedimentary layers that the X part is exhalative, okay, meaning there were hot springs coming up through the bottom of the ocean, hot fluids that exhale zinc, lead, silver, metals like that into blankets, into layers within the bottom of the ocean. All right. So these SEDEX deposits, they're similar to VMS in many ways, but they don't necessarily have that direct volcanic association. Most of them are hosted by sedimentary rocks like muds and shales and fine grained rocks like that. And oftentimes when they are deposited, layers of almost pure sphalerite, which is zinc, and galena, which is lead, and they're mixed with muds and stuff. And then when they're brought up onto the continent, they're abducted, effectively, or brought up onto land. They often go through a lot of squeezing and pushing and squishing around where it deforms the rocks. Okay, so the image over here on the right-hand side shows you the beds of these metals and how they've been deformed. They've been squeezed and folded and whatnot. All right, but they have a feeder, so they have a hot spring feeder coming up from below, and then they have a blanket-like geometry to them. All right, let's go to the next slide. These things often form in basins, fairly big basins, that can have little compartments and different areas where these deposits can form. You can get side basins, you can get a bigger basin, like in the Red Sea right now. Believe it or not, there's a SEDEX deposit forming right now. I kid you not, at the bottom of the Red Sea. Okay, these tend to form in areas where a continent is ripping apart. It's basically pulling apart, and the land is subsiding in response. And as it does, the ocean comes in and forms a big bay or a sea like the Red Sea. And then you get sediments being deposited, shales and muds and stuff. And it's in this environment where, as you're pulling it apart, heat is allowed to come up through the ground and start circulating water. And that water that pulls the zinc and the lead and other metals out of the rocks in the crust, and it moves them up to the seabed, and then they're deposited in these layers. Okay, but you can see these things form oftentimes in clusters and families, like you would see VMS deposits. So they can form in little sub-basins, side basins, and Okay, many deposits over a period of time too. Okay, it's not just like one event done. It's like one event, more sediment, one event, more sediment, more, again and again. All right, let's go to the next slide. Okay, one of the biggest SEDEX deposits in the world is called Sullivan, and it is in southern British Columbia. Okay, it's a monster of a deposit. The numbers that I've seen for it range anywhere from about 150 up to 180 million tons. In this slide here, it says 155 million tons, 5.7% zinc, 6.6% lead, so it's kind of almost an even balance of lead and zinc. Silver's there, but it's not huge numbers. But in terms of its overall endowment, yeah, that's a granddaddy of deposits. Again, this is a world-class deposit. It actually underpinned Cameco, now Teck, for a long, long time. In fact, the smelter is still down there at Trail. But Sullivan was largely mined out a while back. But wouldn't it be wonderful to find another Sullivan? Okay, you can see it's a blanket-like deposit. The reds and the oranges are the sulfides. The purpley stuff that you see going up, that's that feeder zone. You get things like fine grain tourmaline. Believe it or not, you think gem tourmaline. No, it's not like that. It's a fine grain black tourmaline forms in the feeders. Very distinct rock type. All right, so this is what we're looking for. Go to the next slide. Okay, so the pink arrow up at the top shows you where the Sullivan mine is. So you can see the inset map in the upper left. We're down in the southeast corner of BC. Sullivan is near the town of Kimberley. And one of the properties that PJX has is this Dewdney Trail property, the green one up in the upper right. Okay, and it's this new discovery that they have, this Dewdney Trail discovery, or on the Dewdney Trail property, that I think these guys have stumbled across our next Sullivan. Okay, that picture I showed of the model with the basin and multiple events happening, I think this is another major zinc-lead event within the same basin that Sullivan formed. All right, let's go to the next slide. Now, this geologic map shows you the different rocks that we have. Okay, these are Proterozoic, so they're over 1 billion years old, just for reference. These are fairly old rocks, and they're in packages. Okay, and this Aldridge turbidites, that package actually hosts Sullivan, but it also appears to host this new discovery over here on the right-hand side, where those red and green dots are. Okay, so this Estella mine was a historic mine that was there. My view is Estella was actually probably a feeder zone for a SEDEX deposit, and now these guys have found the Sullivan type bedded deposit. In my view, I think they're onto a major discovery in basically the same kind of rocks. Let's go to the next slide. Okay, why do I say that? Now, these guys have done good old-fashioned boots on the ground work. Okay, now this area that you can see the guy standing on this very steep slope, that's a talus slope. It's basically rock that's shed down from a very steep cliff or outcrop above. That was largely hidden, obscured, and inaccessible until a forest fire came through here recently. And they were able to get in there, and they started wandering around on this talus slope above the old mine, and they found, lo and behold, chunks of bedded sphalerite, the zinc, and galena, the lead. Okay, and the pieces of rock that you can see close-ups of over here on the right in the bottom, they're folded. There's a bit of folding in there. If you have to look real close or go on their website and look real close at the images, you'll see there's bedding and there's folding in there. Looks just like Sullivan. I mean, unbelievable, uncanny. Very good tenor of zinc and lead and silver in those rocks. Okay, this is Sullivan mineralization, and it's right in the same belt of rocks as Sullivan. Okay, that's great. That's a good start. Let's go to the next slide. But guess what? They worked their way up the top of the hill, and they found it in outcrop. These samples actually came from outcrops of the Aldridge type rocks, the mudstones and stuff, or shaly turbidites up at the top. And there were beds of zinc mineralization within this sequence. And they sampled this out of outcrop. That is, in my view, a discovery. Okay. And they found, several meters of this stuff up there. Okay. So basically, we have a discovery of outcrop with good zinc, lead, and silver in it. I mean, this is amazing stuff, guys, right in a district that hosts one of the biggest SEDEX deposits in the world. Let's go to the next slide. Here's a spectrum of assays from the property that they've collected. I think this includes mostly talus samples. Maybe it includes some of those outcrop samples. But it's typical grades that you see for Sullivan. I showed you the grades earlier, 5.7% zinc, 6.x% lead. Look at the numbers over here. A little bit less lead, but really good zinc numbers, I think that's fantastic. And the silver is actually a bit higher than they typically saw at Sullivan. That's great. There's even a sniff of copper in here, which is interesting. There was a little bit of copper at Sullivan. This has a bit more copper. It even has a slight sniff of gold in it. And then other trace elements, like indium was always an important byproduct out of the ores at Sullivan for years and years. So go to the next slide. Okay, here you can see their soil data. Now, they didn't get soils over everything, but you can see above the old Estrella mine there, which is in that rectangle, that black rectangle, there's a very well-defined, discrete zinc anomaly in those Aldridge age rocks, okay? And it's running hundreds, if not thousands, of ppm zinc. that says there is something big there. Okay, that's to get a sense of scale. That zinc anomaly is something like 2 kilometers along strike, from northwest to southeast. Go to the next slide. Same in lead. Lead actually extends, the anomalism extends further to the northwest. But again, you have at least 2 kilometers of really strong lead values. All right. So, wow, these guys might be onto something huge. Okay, let's go to the next slide. Now, interestingly, okay, this area where this talus occurred, this stuff that shed off the mountain, has a dike, a little tiny thin red dike that runs up the dip slope or the face of the mountain. And for many years, people looked up in there and they said, "Oh, that's an intrusion. That's a magma rock. Like nothing to see here." But these guys, they found this rock in talus down at the bottom with zinc, bedded rock with zinc. Oh my gosh. So they climbed up the mountain, and guess what? They found outcropping zinc in the bedded sedimentary rocks. And they said, this isn't an intrusion. This is a dike. They could see that the thing had a very shallow depth to it, and that where Mother Nature had eroded through it, there was sedimentary rock underneath. In fact, there's a big package of these favorable Kootenay King deposit equivalent sediments. Okay, now it's a bit up section from Sullivan, but what did I show you in the previous slide? These SEDEX deposits occur in multiple levels within, in the stratigraphy of a basin as they form. Over here on the right-hand side, you can see the Sullivan deposit for scale. Okay, so the idea here is that could you have a Sullivan deposit where these guys have found this in that? Absolutely. Okay, and what I've done, like the orange lines are kind of hard to see, but I took the liberty of kind of sketching some drill holes about how they're going to approach this to show, they're going to have platforms stepping up the mountain, and they're going to drill down through the stratigraphy to try to catch as much of the stratigraphy that's dipping off or dipping, into the ground here to find those beds of zinc. If they hit big, this could be really big, really, really big. It could be an amazing story. Very happy we got into this one.